In this video, we will learn about resistors in a parallel connection. So when resistors are in a parallel connection, one thing we have to know is that they will share a common node. Okay, so looking at these two resistors that I have here, the 10 ohms resistor and then the 20 ohms resistor here, you see that they share a common node. The node here is this white point that I have here. Okay, that's the node. So these two resistors are connected to these same nodes. The 10 ohms is connected to these 2 points, and then the 20 ohms is also connected to these 2 points. Same thing happening here. The 10 ohms is connected to these 2 points here, okay, and then the 20 ohms is also connected to these two same points here. So you see they share a node. And we call this point here the node because it's a point where currents gets separated or currents sum up together or come together. So looking at this point here, okay, you see that the current which is coming from the source here gets separated into two different currents. Okay, so we call this point here the node because the current has been separated here. Same thing that's happening here. The currents then come back together here. Okay, the current then come back together here. So you call this point here also what? The node. Okay. So one thing also we have to know about resistors in a parallel connection is that the same voltage flows across each of the resistors. So with these two resistors that I have here, the same voltage flows across them. So this 15 volts that I have here, the same voltage that will be across these two resistors. So now let's learn how to calculate for the value of what total resistance for resistors in a parallel connection. So looking at this, you see that the current from the source, which are named I, okay, gets splitted here into I2 and then I1. Okay, where I1 is flowing through the 10 ohms and then I2 is flowing through the 20 ohms. So I'm going to name the 10 ohms as R1 and then the 20 ohms as what? R2. Okay, so from ohms law, we know that what voltage equals the product of what current and then resistance. Okay, so if when you find the total current and then the total resistance, it will help us what find the voltage or calculate for the voltage in this circuit. And then we can find this current I here by adding I1 and then I2. So we can say I, which is the total current in the circuit, equals what? I1 plus what? I2. Okay. So if I want to calculate for the current for this circuit, I can use any of these formulas. Okay, but let's focus on the formula I have here. The voltage equals what? Current times resistance. So if I want to find current from that formula, that would be voltage equals what? Current times what? Resistance. So making current the subject, that give me current to be equal to what? Voltage over what? Resistance. That's the total voltage over the total resistance in the circuit. Same way, if I want to find the voltage in the 10 ohms resistor, okay, since this is the same voltage that will flow across through there, I'll use the same V here to represent the voltage because this is the same voltage that will flow across each of the resistors here. So if I want to find for the current in the 10 ohms resistor, that will be what? I1 will be equal to the voltage about resistance, which is what? R1. And then same way, if I want to find for current in the second resistor, that will be what? I2 will be equal to what? Voltage about the resistance value R2. Okay. So from all these formulas, let's come and substitute them into this formula that I have here. Okay, so this will give me voltage over resistance, that's the total voltage over the total resistance. That will equal to what? Voltage over R1 plus voltage over what? R2. Okay, that's voltage over what? R2. Okay, so this is what I have here. So from here, you see that what voltage is common to these two resistors here, the V here. So I'm going to factor that one out. So that will be voltage over resistance equals what? Voltage out of the bracket 1 over R1 plus 1 over what? R2. Okay, that's what I have here. So now I will want to get rid of what this voltage here. So I'm going to divide both sides by what? V. So that V times 1 over V times what? 1 over what? V. When I do this, we can get rid of the voltage here. Okay, so at the end, we have this to be this to be 1 over R. That's the total resistance to be equal to 1 over R1 plus what? 1 over what? R2. Okay, so this is the formula that we use to calculate for the total resistance for resistors in a parallel form. Okay, so when you have more than two resistors, we can continue. So that 1 over R3, okay, plus 1 over R4 plus 1 over Rn. That's to the last resistor value. Okay, so that's how to calculate for total resistance for resistors in a parallel form. Okay, so in my next video, we are going to learn more about series and then parallel connections. Then we solve more examples on this. Thank you very much for watching this video.